Welcome to The Objective Thinker. I'm your host, Maximus Jatavius. This is episode 2 of The Objective Thinker, and I would like to welcome Hefe Patterson to the show. Welcome, Hefe.
Thank you. Happy to be here.
Good. Glad to see you. So today we are going to be covering a multitude of different topics, mostly jumping into a flat Earth. But first, before we wanted to do that, we wanted to start off and go over all the things that we are currently taught about the world that we live on. Obviously, most of us believe that the world's a globe. We've seen it from images from NASA. We see it from outer space. We live on this globe. Would you say that's what you believe too?
I would. We live in this infinite, never-ending nothingness of the void that we call outer space. It's a part of the still expanding and ever-evasive and ever-elusive universe that we just keep learning more and more about. And it's just it's a crazy, chaotic world out there. But we live on this tiny little blue ball, suspended in the nothing. We're held together by gravity, and the theory of relativity keeps us from feeling motion of the planet as it hurls through the universe at incredible speeds. And we have all this life, and everything's just here on our planet, and it's just little old us, and we've yet to discover anything out there to suggest that there's additional life forms out there. So I think it's important, though, that before we continue any further, we can't encourage enough. Open that mind of yours. Open that mind. Have the ability to be objective about what you're hearing today, and by all means, fact check everything that we're talking about today. Again, no PhDs in this room. Just a couple of guys, that regular Joes, if you will, and we're trying our best to look at things from a direct, observable reference so that we can have a good understanding of what we're talking about, instead of just hearing what everybody has to tell us. So even though you're listening to us tell you things, by all means, please do your own research and just try to open your mind. And when you hear things that we're going to talk about today that just seem so crazy, just do me a favor. If you have to hit pause, come back to it later, but please do not turn it off. Do not tune it out. It's only your own self-reckoning that is your demise. So try to be objective. That's what I got to say.
Sure, and I think that's what the main focus of The Objective Thinker is to promote critical thinking, look at all things objectively, try to take all the evidences in that you can. So one of the things we're going to cover today is what science has taught us. I think you hit on it a little bit, but science has taught us, we exploded out of the Big Bang, and that was, a grain of sand that exploded into everything we observe in the universe that's infinitely expanding. And like you had said, we're sitting on a drop of water just floating in that nothingness, and we're so fortunate to be here. Science has all these different things, and one of the things I wanted to look into was, how fast does the Earth actually rotate? So I looked that up, and if you guys want to follow along with us today, just Google these things. Earth rotation speed. And the definition of that says that the Earth rotates once every 23 hours, 56 minutes, actually. And that there is roughly a speed of rotation of 1,000 miles per hour, 460 meters per second. Yeah.
That's impressive.
That's really cooking. 1,000 miles an hour. That's faster than the speed of, say, sound, even. Right? So that the Earth is actually rotating faster than the speed of sound. That's pretty amazing. If you look up the Earth path around the sun speed, you'll find that we are traveling, the Earth is rotating around the sun at 18.5 miles every single second. So just to put that in miles per hour real quick, let's grab a calculator here. 66,600 miles per hour. I've heard that's rumored to be somewhere around Mach 88. That's 88 times faster than the speed of sound.
We're cooking now.
We're really moving. Then from there, I mean, we'd have to get into the speeds of how fast our solar system is orbiting around the Milky Way galaxy.
I do believe that it's close to the speed of light. It's up there. I can't remember the exact number. Man, we are seriously moving.
Like millions of miles an hour. We're hurtling through outer space because all the galaxies are flying away from each other according to the Hubble telescope. So
we got the Big Bang. Everything's moving away from the Big Bang. And from that Big Bang, so that's one speed. Then the galaxies were formed, and they're spinning, while they're also moving away from the Big Bang. So now we have two speeds. We have the rotation of the galaxy, and we have the speed to which it's flying away from the center of the Big Bang. Now within those galaxies, we have stars, and those stars have, for us specifically, we are a planet going around the star. So now we are going around the sun. That's one speed, to which the sun is going around the galaxy, which is the second speed, and the galaxy is moving away from the Big Bang, and that's the third speed. But then we have yet another speed, which is the speed of which our Earth is spinning while it's going around the sun, which is yet a fourth speed. Now each one of these, it slowly starts, it begins this track of slowing down, but in essence, we're talking, it starts from near the speed of light, trickling down to the slowest speed of around 1,000 miles per hour, which is how fast our Earth spins at the equator, and it's hurling through space. So put that into perspective, and it's really hard. You start to see this insanely, rapidly, quickly moving, expanding universe.
Right, and I guess when we go out, though, do we observe any of that? Do you feel that motion or that speed anytime you ever, go outside?
Well, and that's an interesting question. I personally don't feel anything. So let's talk about that for a moment. The reason why we don't feel anything is, here's the thing. With the heliocentric model, and for those of you that are new to this is going to be the spherical ball Earth model that we're all told that we live on, this beautiful blue marble, as it were, is that everything is based off of numerous theories. It's kind of weird, is that theories become fact in certain circumstances and vice versa. Because in the science world, things are always ever changing and what have you. So what does that mean? So why don't we feel the spinning of anything? Well, science tells us that it's the theory of relativity. First, we have gravity, which is holding us to the Earth. And because we are relative to the Earth's motion as it was rotating and spinning around and hurtling through space at whatever hundreds of millions, bazillion, gazillion miles per hour, we don't feel it because it's relative to us. Additionally, gravity in and of itself is also a theory. And yet it's not. But it is. But it's not.
Well, that's because theory and scientific theory mean two different things. And scientific theory means it's a fact because there's an abundance of evidence to support it. However, it does still allow room for a new experiment to come in and disprove all the old ones, therefore nullifying the theory.
So now, having said that, now that we have a decent understanding, and believe me, there's plenty more things to discuss, and feel free to shoot some comments below. Then should you be coming close to your time where you're like, I'm almost to work right now or to my destination, you can't listen to the rest of it, hit pause, come back to it, because it's going to get even more interesting.
Yeah.
So having known all that, we're spinning, we're moving, we're suspended, we're the only people in existence, and there's no more beings that we've sought, and there's bazillions upon bazillions of stars out there. Now let's talk about a flat Earth model. So the flat Earth model, Dirty, take it away.
It is, I think I don't know if I brought this up earlier, but if you look for images of flat Earth, you'll find the two first maps, and those were referred to as a Gleason map. And those were maps that were made by the USGS, which is the United States Geological Survey. They do all the mapping. So they actually have their own flat Earth map, which is kind of funny. So when we dip into a flat Earth theory, this is where the cognitive dissonance is going to kick in. This is where we're going to talk about how all those things we just talked about that you were taught to growing up may be absolutely incorrect. They could be some kind of false doctrine, so to speak. And we're going to cover more of these things as we get deeper into episodes, and there will be more evidences brought up as we go down this hole, basically. So, on the flat Earth...
So talk to me about this map. Let me see this map here.
Sure. So, when you look at the flat Earth map for the first time, imagine the Earth as an orange, if you will. And if you peel apart the orange from the bottom, Antarctica is at the bottom of the globe. And Antarctica, basically, it's stretched out to this ice wall that encompasses the globe now that we've flattened it down on a plate. All the continents will still fall inside, and it'll be very close to what you've been taught as far as where the continents fall. It's a little different, but if you're following along in the pictures here. And the North Pole is at the very center of that plate. You can still circumnavigate the globe. You could travel all the way around the world going east to west still on this map and think that you've gone around a globe, because north is always going to be north, south is always going to be south still, and east and west, they still work out as well, so you can circumnavigate it. But you cannot circumnavigate it north to south. And I think that's an interesting point. No one's actually done that before. No one's ever circumnavigated the globe from pole to pole and gone around in a complete circle around the globe that way. And I think that's a very telling piece of evidence that may lend the flat Earth theory some more credibility. But as we say, we try to be objective as these things as possible. I challenge you to go find somebody that has circumnavigated the globe that way. Your thoughts?
Well, Mike Horn. It was recently brought to my attention that Mike Horn actually has circumvented the South Pole. And he's got his whole website up, huge adventurer. Something that I kind of found kind of ironic, I guess, extremely ironic. When you look at his, because you can actually live track him on where he's at. I mean, this is according to his website, of course. You have this map that he pulls up, and it shows you all these places that he went when he travels beyond South America over to Antarctica, and it just keeps going straight down. The problem is that the map that he's using is a flattened out model of a globe Earth. So when he hits the bottom of Antarctica, where the South Pole is supposed to be, it's just this big line. It's a straight line going the perfect. It parallels the exact rim of the map at the bottom, and then all of a sudden it just comes back up again. And
right.
It just really strange for me. Of all the maps to use that map specifically, it was just really ironic, and I just don't understand why. But in any case, he has claimed to have done it. But the thing that I think gets a lot of people is, if there's now keep in mind, people, that just because this is one flat Earth model map, this does not mean that this is the way that a flat Earth appears. Like, there are many theories and ideas of what the flat Earth could look like. There are some people out there that think the world is a cube. So
there's people that think it's hollow.
There's all kinds of theories out there, and we'll try to touch on all of them here on the Objective Thinker. But in any case, when you look at these, I found that when I first looked into this, that I got kind of sucked in on the first flat Earth model that was presented to me, and this is the exact one that we are presenting to you. So there are other ones. There are people that think that, well, Antarctica is not the edge, but rather there is additional land beyond that. Now, I believe that there was a Admiral Byrd, if I'm not mistaken, that actually went down to Antarctica. And he had actually gone on record and claimed that not only did he find an abundance of natural resources in Antarctica, but he also found land beyond the land of Antarctica, which he claimed was about as big as the United States.
Yes, another whole continent, he had said, that they had found beyond Antarctica, which on a globe, if you go beyond Antarctica, aren't you just coming up the other side of the globe? And this took place just after World War II. It was called Operation High Jump, and there was also an Operation Deep Freeze. There was the follow-up mission. And those are very highly speculated operations. I encourage any critical thinker to look into those, read up on them. They will apply to a lot of these other things we are going to discuss later on. So, and the other thing I wanted to say real quick to highlight on this map, and to reiterate what you said, this isn't a be-all, end-all map. This is a relatively new theory that's coming out. It's emerged in the last 3 years, and there's a lot of research being done into it. So it's constantly evolving theory, just as any other scientific theory is. And I encourage you guys to treat it as such, with evidences for or against, and any proofs you guys can come up with. I highly encourage that.
Now, Dirk, can you touch on real quick something that I have found when I first started looking into the Flat Earth thing was Flat Earth Society, and it took me a while to figure out that the Flat Earth Society does not represent the belief in all people that believe in a flat Earth. So apparently the Flat Earth Society has their own set of ideas and views that are actually contrary to a lot of... I mean, I think, didn't he say he fell off the edge and was held on by a little rock, and he has that rock, he carries it around with him?
Right.
It's like the leader of the... I mean, it just sounds completely ridiculous.
So how the Flat Earth Society actually got its start was in the late 1800s and the early 1900s. The Flat Earth theory was actually alive and well. It was actually taking off. A lot of people were starting to catch on to this. And someone who wanted to discredit them started a Flat Earth Society, and they basically spread disinformation about the theory in order to make it look silly and ridiculous. Like, they've claimed that the moon's only 4 miles away, and they say things like this to really make the whole theory look ridiculous. Because the first time I ever heard of the theory, like I said, it is absolutely preposterous. There's no way the Earth's flat. But after researching into it for the last 3 years, I can tell you that there's a lot of supporting evidence that would say that it is, and that we are currently being lied to about a lot of different things. So
we come to the next topic.
Gravity.
So I'm probably wondering, what are we talking about? NASA has shown us a bazillion photos. NASA has gone to the moon. NASA has... the moon itself appears to be spherical. We've seen the other planets in our solar system. They're spherical. It's on and on and on. This is where really... I'm running out of tinfoil here. I keep putting more and more tinfoil on my head now. And in essence, if you look at it objectively... Let me start off like this. I was a huge NASA fan. Huge, man. I wanted to be like every other kid. I want to be an astronaut. Yes. I want to go to I want to be the Tom Cruise of the next Mars and the next dimension of galactic empires or something, man. That's what I wanted. I wanted the laser beams, the whole bit. So when I started looking into this stuff, because my cognitive dissonance kicked in immediately when someone was like, "Oh, NASA's a bunch of lies," I immediately was like, "No way. That was my dream. You just crushed it. I'm never going to listen to you again." It took me about a year to actually come back and revisit it and be objective about it. So let's talk for a minute about NASA, because obviously you have to overcome that hurdle to really even come to the conclusion that that the flat Earth could even be possible. Now, to add to it, I personally don't believe that the Earth is flat, but I'm almost 100% confident that it's not what we were told that it is either. I don't really know what it is, but there's just too much supporting evidence contrary to what we're being taught about the heliocentric model, as opposed to what you can actually observe directly for yourself. And I'm talking really, really easy little experiments. So you just go to the beach, pull out a level, make it substantially long, we'll call it 4 feet, and then just sit back and look at the horizon. There's not any curve to be seen. The elusive curve. But not to get talked on that, let's go back to the NASA.
Let's go
NASA.
to Earth. Let's
Hit
go
me
just
with
type.
It. Hit me with it, Dirty.
So yes, on a flat Earth model, NASA is the ultimate deceiver, and they're lying to everybody. They're deceiving the world with their NASA missions and their photos of Earth. If you Google image Earth right now, you're gonna click on the first one you see there, and it's the famous blue marble image that we've all seen. And if you look at all these different pictures of Earth, you'll start to see that, wait a second, there's all these NASA images of Earth, but yet they're all different. So which picture is really Earth? There's a side-by-side comparison. If you take the last 8 images that NASA's released to us all, called blue marble images, and you look next to them, or look at them side by side.
Which, might I add, they're very hard to find. Actually, I think they've actually started taking them off of the NASA website, because I remember personally seeing them there, and now I'm not being able to find a lot of these images because when I started doing my own research, I went to the NASA website, and I encourage you to do the same. You will start seeing that there'll be images that are there, and all of a sudden they're not there anymore, and they're very tied into the concept of the heliocentric model. But somebody has gone to the extent of saving these photos. So, again, if you're new to this and you're going to look into it, I don't know if you're going to be able to find these photos. I guess you're just going to have to take my word for it. They were there, and now we're going to show you here. So if you look at this photo here, you have all these different planets of Earth that are side by side, and they're all they're all labeled with the year to which they were taken. And you're seeing some huge discrepancies in these photos. I mean, ridiculous. I mean, one here in 2012, you got the United States, and it's
the whole northern
hemisphere,
hemisphere,
the entire planet. Yeah, it's actually it's ridiculous. And you look at another one, and North America is substantially smaller, and it's more proportionate to what we believe. And then there's another one where you can see that the clouds were actually copied and pasted all over.
Look at all the different colors of the oceans. Look how different the colors are from picture to picture. It's like, do the oceans get this dark blue, or in this one they're this light blue? And I mean, we're not talking like little sections of the ocean. We're talking the whole Pacific Ocean is a different color than it was 10 years ago.
In any case, sorry about that, technical difficulty. In any case, you have all these different images of the Earth, and then you start wondering, well, wait a minute, what if these were all different sizes and they're all different proportions, and each one looks drastically different from the other one? And it's not like, well, back then they had different kinds of cameras and lenses. I mean, why would the continent suddenly grow a couple 1,000% bigger than what it is on another picture? It just doesn't make any sense.
So I'm gonna go a little bit conspiracy theorist on you here real quick. And I'm going to tell you that all these different blue marble images, they're composite images. NASA has said they have to be. And the reason for that is that right now we're stuck in low Earth orbit, which means we don't have a rocket in our arsenal right now that's capable of getting out far enough to take a picture and fit the whole Earth in that one picture right now. There are some satellites that they claim to exist. There's the Japanese Hawara 8 satellite that is a weather satellite, and it takes pictures of Earth every 10 minutes, and it puts them in a time lapse. But there's no live feed video of all of Earth. There's the International Space Station, but again, it's stuck in low Earth orbit. It's so close to the Earth that you can only really see a fraction of the Earth from how close that is. So I guess my big question is we've sent some satellites that have even been claimed to have left our solar system, but yet we don't have any satellites in place, in over 50 years of space travel, that are just pointed back and looking at Earth, where we could just watch it rotate all the time in one continuous shot. And when I asked these questions on the NASA Facebook page, some of the NASA fans kind of came at me and said, that's a waste of time and money, because we should be more interested in looking outwards into the galaxies than turning around and looking at ourselves. But I don't really agree with that kind of line of thinking here, because even our own oceans, we've only explored 5% of our own oceans. Yet we're worried about galaxies far away. I think there's a lot to be learned here, just even on Earth yet, and it would make a lot of sense to have a camera of Earth rotating at all times.
Well, let's see. If I'm a part of NASA, and mind you, for those of you new to this flat Earth thing, it's very much on the rise right now. I mean, insanely on the rise. You can't look at anything astronomy related at all without finding somebody commenting or someone saying something about how it's fake or anything. It's crazy. So, if I were NASA, and I have all this, I mean, we're talking about the rocket scientist of our existence. These are the smartest guys in the world, right? And we're starting to see that they're losing the faith of the people to which they research for. I mean, how hard would it be to just come on? Let's just show you real quick. Let's debunk this once and for all. Just turn a camera around and show me the Earth.
Isn't there the Hubble telescope that sees galaxies that are hundreds and thousands of light years away, and they can't turn it around and show us all of Earth?
Well, and then there will be some that'll say, well, there have been photos of the Earth, but if you look at one,
well, the blue marble photos.
Why don't you show? We're going to pull this one up here. It's of the moon, the backside of the moon. This was pretty recent, actually. It's the backside of the moon, and how it compares in relation to the size of the picture of the Earth that was taken from the Apollo 17 mission. So,
that photograph was actually taken by the Japanese satellite I had referenced earlier, the weather satellite, because it is far enough away that it actually captured the moon in between the satellite and Earth, and that's how they got that picture.
So, if you're looking at this picture now, you see the difference in proportionate sizes. It just the Earth is massive on one, but then it's nowhere near as big on the other one. And it just doesn't, it's not lining up with what my eyes tell me. So, does that mean that this is a fake image? Well, it definitely doesn't look proportionate compared to what it should look like, in my opinion. Because that would mean if you're standing
if you were standing on the moon,
the Earth is going to be, the Earth is gigantic. You wouldn't even...
It'd be the whole sky to you, almost. Or like half the sky to you. It would be so enormous. I mean... Yeah, it would be like trying to picture if the moon were, let's say the moon on Earth to us was 100 times closer than what science tells us. You can imagine how big the moon would be then, right? If it was 100 times closer, it'd be gigantic in our sky. It'd be 100 times bigger than it is. And that's what we're saying in this image, is if you were standing on the moon, Earth looks so large that it would take up the majority of your sky. In fact, it would be so close that wouldn't the light be reflecting off Earth, making it light there as well?
It's very possible. I mean, there's you look
I mean,
at
it
these
would
kind
be
of
bright there
photos.
all the time.
Yeah. Well, I mean, and it continues. So, and this
Well,
all
here's
does
another
pertain
conspiracy.
to a flat Earth model, because it's to show that
I want
NASA
to just touch
is
one more
inconsistent.
thing. Sorry, we're having a delay issue here, and I keep cutting you off, so I apologize for that. I want to touch one more thing on these blue marble images. There are people have pulled these images into Photoshop, and they have found evidences of these clouds you're seeing being replicated using a clone tool from Photoshop, where you're going to find clouds that look like the exact same other clouds. They've just been stamped around in an area, and clouds don't form like that. You're not going to get the exact same pattern over and over and over again. And that's out of these same NASA blue marble images. Your thoughts?
It's you can't make this stuff up. I mean, you could try.
Right?
It's just not consistent. Well, I mean, before we get too hung up on just this one thing,
Just NASA,
go down the list of NASA for the. These are all accusations, so bear with me.
Yeah.
We didn't go to the moon. The moon rocks are actually petrified wood.
I heard that one too.
The moon is stuck in a synchronized lock with Earth. It's called Tidal lock, which means you only for many of you probably don't know this. I didn't know this. You only see the same side of the moon every single day for your rest of your life. You will never, ever, ever see the other side of the moon unless you can go behind the moon. And if you don't believe me, look it up. It's called tidal lock, and it's when it means that the moon does spin as it goes around, but because it's always spinning at the exact same speed as the Earth, it's now caught itself in this way to where as it's spinning, all it's doing is showing you the same side of the moon all the time. So the backside of the moon is just this big mystery. And I didn't actually know that. So continuing on, though. You watch the videos from... let's talk about the moon landing. Think about how crazy it would be to film something live where the risk of death on national television is astronomical, right?
Sure.
We're talking about landing on the moon for the first time ever. And mind you, if you look at all the tests for the lunar lander, that it actually never was a successful landing experiment that ever occurred here on Earth. They said, well, it's going to work fine when it goes to the moon, though, guaranteed. So even though it never actually successfully landed here on Earth, they went ahead and put it out there. And this is, go ahead and fact check me. This is the kind of stuff that really starts pointing you in a weird direction. So they go to the moon. They film it live.
World's first live stream.
Right? And not only that, but he's talking to the president on the phone from the moon. And you run into a lot of discrepancies there. There was the first successful landing of that lunar lander because it actually was on the moon, so they said that it worked fine. There's no dust on any of the legs from when the thruster that's on the bottom would create a big impact crater from landing.
Yeah.
And you don't see any dust anywhere. It's crystal clear. All the pictures of all the astronauts when they're up there on the moon, you don't see any stars anywhere on any picture.
Which science explains away as the light emitting from the moon being reflected by the sun is so bright that you just can't see the stars. It's like daytime here on Earth.
Okay. So, in addition to that, you have astronauts that when they were in Neil Armstrong's interview, when he got back to Earth, with the other astronauts that were with him, they actually said during their interview that they don't remember seeing any stars ever. No stars.
Wow.
Not when they were going to the moon, not when they were coming back from the moon, not while they were on the moon. No stars. They could only see the moon and the Earth. So we're talking about...
That's strange indeed.
Right? And then the Van Allen radiation belt. In case of you, for most of you that don't know, the Van Allen radiation belt is a belt of radiation that it's generated by the magnetic field to which Earth has from its north and south pole, and it deflects all the radiation particles from deep space and our own sun from entering the Earth. Because if it did, it would just rip our planet to shreds. We would all die horrible deaths. So we were able to figure out a way to get through that Van Allen radiation belt, which is out of low Earth orbit, and get to the moon. The problem is that now we don't have that technology, which brings us to the next thing about NASA.
Wait a second. Haven't you seen the moon? Have you seen the moon lander? You telling me that tinfoil? That thing's made out of tinfoil that I've got in my kitchen.
Well, it's on my head right now.
You're telling me that? Oh, yeah. Same stuff you're wearing as your hat. How did we make it through the Van Allen radiation belts? If you've looked at pictures of the lunar lander, that thing looks like a high school science fair project that somebody gave these kids a lot of paper mache and a lot of tinfoil and said, hey, make this thing look spacey. If you're asking for my opinion.
How did we get through that then, but we can't get through it now? And this is real stuff here, people. Fact check me. Do it. Do your own research.
Well, NASA has lost all of the telemetry data from the Apollo missions. They've said we've lost the technology.
No, they didn't. I don't believe it.
Yes. we've lost the technology to go back to the moon because we just don't make those rockets anymore. We just stopped, and then all the factories that made those rockets, well, they just kind of went out of business, and it's kind of just a painful process to bring those back. And when I've said this to people, I've had people liken this to, I'm like, hey, did you just happen to know the piece of machinery that helped humanity achieve its greatest single achievement, going to the moon, is just missing? That we've lost it? They go, well, that's kind of like, how we can't make certain classic cars anymore, It's not a big deal because, the classic car, it's kind of, most of them don't get restored because there's just not a lot of parts for them. And I'm like, are you kidding me right now?
We're talking about leaving the planet, the biggest achievement in human history. I mean,
right.
What? What do you mean we lost the footage? Better yet, we destroyed the technology? That sounds like intent right there. We destroyed it. Not, we accidentally broke it. No, we destroyed it. So, and this is real stuff, guys. Check it out for yourself. So, in addition to that, we could talk about this all day long. It just never goes away. So, look into NASA for yourself, and it will come back up in future conversations.
We've spent way too many minutes just on NASA, just alone here. So I want to get back into one other thing too, real quick. Is it flat Earth, right? So once you get past the NASA stuff, you'll start to look and you'll find these large flat areas all across the Earth.
That should be impossible. What is the formula again? 8 inches per mile squared?
Yes. And that was developed by the very first person who theorized the Earth was a sphere, Pythagoras. And Pythagorean theorem says 8 inches per mile squared. Well, the world's largest salt flat by total area is 4,086 square miles.
Wow.
So there should be a lot of curve in those 4,000 miles if we're squaring the 4,086, and then we got to time it by the 8 inches, and then you got to time it by 12 inches to make it back into feet. Oh goodness, we're going to start getting crazy math numbers here. There's no curve there, though. And it's also observed every time you're on an ocean or near a large body of water. You're going to notice, like you had mentioned with your level, it's perfectly flat. So let me ask you this. Is it a sphere? Neil deGrasse Tyson, he says it's more pear-shaped. It's an oblate spheroid. It's a little bit more chubbier down at the bottom than it is at the top. Well, there's all these large...
I'm seeing on the photos. It looks... I mean, I have to take a ruler to it, but it looks really like a perfect, complete circle sphere here.
Well, yeah, and all the blue marble images, yeah, it looks like a perfect blue marble. That's why they get called that. But with all these large flat areas I'm describing to you, shouldn't it look more like a 20-sided die you'd use Dungeons and Dragons play? What is the real shape of the Earth here? Is it flat? Is it a sphere? Is it an oblate spheroid that's pear-shaped? Is it a 20-sided die? I don't know. But I do know this, that when science tells me that I'm spinning around at Mach 88 through interstellar outer space, that this is our spaceship, they like to call it. Earth is our spaceship, and we're flying through outer space in it. Why don't I feel it? When I hurtle down the road in my car, I sure feel it. But I don't feel anything as we're hurtling through all this outer space.
And so comes the theory of relativity.
Relativity.
Right? It's never ends. So let's talk about that for a second. When does, and I have not been able to find this answer, so if any of you out there happen to have a link or something to send to me so that I can look at it for myself, because I'm still researching this is just ongoing, the Coriolis effect, okay? Or Coriolis, depending on how you want to pronounce it. It's essentially when an object leaves the relative motion of the Earth and now has to account for the spin of the Earth, or the curve of the Earth. So, we often relate this, and it gets referenced when we're talking about a bullet. So a bullet leaves a barrel of a weapon, it travels down range, and it leaves the relativity of the Earth and it has to account for where that projectile is going to impact, considering that the Earth is going to spin while it's in flight. So as it's going through the air, the Earth has spun in its normal pattern, and now it's going to land at a different spot. So you almost have to aim leading the target, depending on your distance, to make sure that the Earth is going to catch up and it's going to run into it. So you're leading the target for the curve of the Earth or rotation of the Earth. Now, what I have not been able to figure out is at what point does anything become no longer relative to the Earth? Now, when we look at space launch travel, let me rephrase that. When we look at rocket launches, we see that when the shuttles take off, or any type of rocket, they go up and all of a sudden they start to curve. Now, the reason why we're told that they curve, I'm sure there are many relations for it, but the general consensus is that it goes up, and the Earth is now spinning beneath the rocket. Therefore, the rocket giving the impression that it's curving, but really it's not. It's rather the Earth is rotating beneath it, which is why you see that all of a sudden the trail of smoke that's left behind the afterburners on these things, and thrusters, it's curving through the air. And people say, well, it's not actually curving, it's the Earth spinning away from it, and that's what you're seeing. I have never seen that with a plane. I have never heard of the Coriolis effect taking place with anybody that flies a helicopter. And I know it comes to self-propulsion and what have you, but my theory, my question is this: when does the Coriolis effect kick in? At what speed or in what relation? Because I would love to do some of my own experiments, and I just can't do that if I don't know when the point is, or even if I'm able to hit that point. My guess is that I can't do it.
Well, my point is this: when people say that, well, the jets don't have to take it into account because they're being propelled, right? But isn't the bullet itself propelled by the gunpowder that shoots it? So, like you're saying, at what point, at what speed do I lose relativity to the Earth's spin? And you're constantly being thrusted in an airplane, or no, you're shot out. At what speed still? There's got to be something going on. Or I would encourage any viewer, like you said, to please come enlighten us. Please come explain it to me, because I just simply don't understand it.
Maybe I'm just a tool, and I just look in a bunch of Crayola books, and I'm just an idiot. So, and I eat the crayons when I'm done, obviously.
They're the tastiest part. It's like dessert after the Tide Pod. Like, I eat my Tide Pods, and then I like to wash it down with a Crayola smoothie to get me going.
So the issue being is that there's just a lot of inconsistencies. Some people take these inconsistencies and say this is proof that the Earth is flat. I disagree. I personally think that inconsistencies prove inconsistencies. So something's not right. The jig is up for me, that's for sure. I just don't know. I found out that there's a curtain. I just haven't been able to see what's behind the dang thing yet. So.
And I think I differ from you in the fact that I've dug for so long. I have an evidence file of coincidences in this thing that you're going to find as you dive into this, that you're going to have a lot of things that you go, that's coincidental. That's weird. I want you to put those things in a coincidence file. We're not going to take them as fact or truth. We're just going to go, we found an anomaly here. Let's stick that in our coincidences file. But if you do that for long enough, as you dig into this, that evidence file is going to get thicker and thicker and thicker until the point you're going to go, wow, I've got like 500 coincidences here. How many coincidences, that old expression, the old adage, where there's smoke, there's fire. At what point are you going to look at this and go, wow, there are so many things here that I cannot explain, that you're going to be forced to maybe look at things from a different perspective. Now, a lot of people, a big part of critical thinking is, what is a reliable source? Most people would say anything with a .gov or a .edu or things like these are reliable sources. And part of the digging into the flat earth theory is going to go, maybe NASA's not the reliable source I thought they once were. Maybe I should dig into their credibility here a little bit more than just instantly trusting everything that comes out of their mouth.
That's it. It just takes a little bit of incentive and just a little bit of motivation. I mean, here comes the big one. Who cares? Why? What does it
Right.
matter? What does it change? Well,
Sure.
here's the big wonder, right? So, okay, guys, so the Earth's flat. I don't care. It doesn't change anything. I still have to pay my taxes, my mortgage, take my kids to school, whatever. I get that. I do. Humor me for a moment. You go down to Antarctica. You find this giant obstacle. It's this huge wall. It goes so high you can't see the end of it. So far both ways you can't see the end of it. You can't get through it. It won't move. And you can't dig under it no matter how deep you go. Are you just going to turn around and walk back home and carry on life as usual? Or is that going to bother you for the rest of your life? Better yet, think about your religious standpoint. Where does that draw to your religious standpoint? Proof of God? Evidence of a creator? To be determined. Are we supposed to know that we live on a flat plane, that there's a dome encompassing us, that we can't get through, that space is a hoax, that this whole thing is one big illusion to keep us indoctrinated so that we don't escape so we don't leave the line, as it were. We stay in line and we don't ask questions because they've already given you the answer. You have the ability to look into these things for yourself. And if I don't know,
and that's
about
where
you,
this
I just
ultimately
wanna know the
leads.
truth.
I think that's where this leads. I mean, the search for truth in the flat earth theory, and this is where it's led me. This is coming from a former atheist, former agnostic. I thought when I died, I was going to go to the great nothing. There wasn't going to be anything after this life. Well, I think this is part of the great deception from NASA, is concealing the very proof that God is very real. He has created Earth. He sits above us in the firmament, and He is really watching all of us.
Well, that's another thing we forgot to bring up. The biblical side of things. We'll just leave it.
Well, sure.
Read Genesis.
Yeah.
Read Genesis,
Yeah,
just the first 3 pages, and tell me what you see there. It's very clear that God made the earth, that He made the firmament, which some people believe is the name of the dome that
the dome.
Yep, and then He separated the waters from below from above, which means that it's actually water that's above the firmament, and just all these weird things, that we are stationary, and that He made the stars in the sky. It's on and on and on. Check it out for yourself.
Yep.
Again, yet another check in the box, as you said a moment, Dirt. Another coincidence to add to the file.
Yeah, when you dig into the biblical side of this, 6 sentences into the Bible, it says He created the firmament to separate the waters from above from the waters from below. It's really, really an interesting. If you like to get into some stuff that's interesting, I encourage you to check this stuff out, because it will definitely open up your mind a little bit to the world around you. Great. We encourage all of you to dig into all of this yourselves. As always, please, please, please use your critical thinking. Be objective. And please check us out on Facebook, on YouTube, and comment. We'll see you next time.